All right, let's do this. Don't think there are any announcements, if I'm not mistaken. So let's get right into it. We want to continue reinforcing our understanding of objects and classes and references and constructors and all that good stuff. And the keyword this, we're going to do that through one big example. And through this example, there's two new-ish things that I want to talk about. Both of these are kind of peripheral, if that's the right word. I don't want to, you know what, I'm going to say it anyway. I don't think either of these are anything a TA should be asking you in an interview, but now that we have more information, we can understand what these very important concepts are that are related to writing software, going to be pertinent throughout your careers and all that stuff, but kind of more bonus content for this part of 116. So let's take a look at those. The memory diagram that we're going to go through with this is critical to 116. You know, all that's very important. But the two things that I'm about to say that we'll get into, they are on the screen. Composition and garbage collection. Composition is very important, but knowing the name, the word composition, not so much. You know, I wouldn't hate it if you didn't know the word. I'm not big on vocab. And garbage collection, it's important to know this concept, but we don't have a way in the tracing tool to even represent this, so, you know, we can't really assess it on your quizzes. Maybe on an interview. I don't think we plan to next week, but it wouldn't be too unfair on an interview. Anyway, let's talk about what these things are. Composition is, I don't like that it even has its own big fancy word for this thing, but all composition means is that instance variables don't have to be primitive types. Instance variables can be references to other objects on the heap. And we're going to see this a lot today. We're going to have a party object that has an instance variable that stores a reference to an array list, and that array list is going to store references to character objects. So we're going to have a reference that refers to something that has a reference, that refers to something that has references, bless you, and go through multiple steps to be able to bounce all over memory to get to the object that we're concerned with, especially when we get to this line. We have 3 dot operators in the same line. Every time we see that dot operator, we're taking a reference and going to an object. So we're going to be bouncing all over the heap when we get to this line. And we can do that through composition because we have references in objects that we have references to, that we have references to another object. It just keeps going and going. This is composition. The fact that one object can be composed of other objects, that's where the word actually comes from. I just say it as, well, array list and character are types, and we can use types for any of our variables. Therefore, just an implication of things that you already know, that variables can store references, and those references can be of any type pertaining to a class in Java, and your classes can define instance variables. Since they are variables, they can be of class types. So it's just a combination of things that you already know. Can you go over where we're supposed to put task2 and IntelliJ? Because a song class file doesn't exist. You create that file. So I did just prep IntelliJ because I think we'll have time to do a little IntelliJ. But you would go to the ratings package, right-click the package, go to New Class, type song. Now I have a song class. That's what you're expected to do from task 2. And task 2 onward, you're going to be creating new classes for almost every task. I was going to say every task, but even thinking of just task 3. Task 3 is released, by the way. Even starting at task 3, we're adding methods to the song class without adding new classes. So I can't say that we're always adding classes. But most of the tasks from here on out, you'll be creating classes. Some of them, you'll even be creating your own packages. And that's how you do it. Just right-click the package, new, and create that file. The other topic is garbage collection. We have 2 really dumb lines right here of code. these two lines of code, you should never do this together like this. What I'm doing is creating declaring a variable of type character named hero and setting equal to a reference to a new character that I'm creating. And then on the very next line, I'm reassigning hero to another new character. What this means is that first character that I created, this character, I got a reference to it, stored it in hero, and then on the very next line, I replaced that reference with a new reference. I created a second character and assigned that reference to hero. What happens to that first character that I created? Because I no longer have any way possible to ever access that object again. Because I threw away its reference. I no longer have a reference to that object. What's going to happen is it's going to be a candidate for garbage collection. That means Java is going to look for any objects that we can no longer reach and delete them for us. So that heap space will be freed up for us because we can no longer access that object. This is a very important, very powerful thing that Java does for us. And it's something that you won't really appreciate until CSE 220, where you're going to be coding in C, which does not have garbage collection. And then you're going to say, holy crap, Java did a lot of work for me. And you're going to learn to really love garbage collection at that point. This semester, you probably just take it for granted and say, oh, cool, garbage collection, whatever. But this is very important. The reason you went through these two lines is because we created a character and didn't do anything with it. We just wasted time, wasted CPU time, wasted memory. There's no point in doing that. So don't actually do this. I'm only doing that for the lecture example. I've had that question in the past, like, why would we do that? No, never. You would never do this. Create an object just to immediately throw away its reference. That's a complete waste. You only do that if you're trying to make a point in lecture. Okay, then a memory diagram. I have the slides, but we're beyond slides at this point. We're going to the tracing tool. The code, though, and it doesn't. But I have IntelliJ. Yeah, just give me a second. Party. Make sure this is what I have in the slides. Good. Got a little extra. Win battle, add character, and party. Okay, all right. I need character. I keep forgetting that when I paste into the tracing tool for my slides, it messes up all my formatting. So I just want to grab the actual code, make sure I'm doing it with the good stuff. Bigger. Need a few line breaks. It's all on screen. Okay. Is that legible? Can everyone see the code? Yes, I see a thumbs up in the back row. That means we good. Okay, so let's start this memory diagram. Let's do this. This one's a beast. Paul said it took him half an hour to go through the memory diagram. I think it'll take me a little longer than that, to be honest. I tend to go off on tangents and explain things a little too much, maybe. But let's do this. So our memory diagram starts with the two lines of code that we just saw for garbage collection, where this first character is going to be created, lose the reference to it, and it immediately is garbage collected. So let's go through this. And character, I made sure the constructor had as few parameters as we can get, which is 0. Is that true? Yeah. 0, so I don't have to keep doing, it was a pain to do the other memory diagram, creating the player with 3 parameters, all calling setters, so I got 3 stack frames. We're going to cut that down a little bit. So we do save a little bit there. First, we need our main stack frame. So main, don't forget your main. We're always creating a main stack frame, a little different than 1.15 in Python, where you did use the global things. We are not using globals at all. Java does not have global variables. There's no need to ever touch globals in Java in your memory diagrams. because they don't exist. This is going to create a variable hero. Hero. Actually, I've gotten pretty quick at this. It might not take me more than half an hour. This is going to be a character constructor. This is going to be a keyword that stores a reference to the object that's being created, since this is a constructor call. I feel like I haven't emphasized this enough, so I'm going to emphasize the keyword this every single time we come across it today. This is in every single stack frame of a non-static method. Every single one of them. The first thing you should put is this. You should just get in the habit of putting this in every single non-static method call, including constructors. Every single constructor. And it's, in the constructor case, a reference to the object that's being created. We don't have an object that's being created yet, so let's get one. This is a party. Oops, this is a character. The parent is this stack frame, which is now color-coded, so we can tell the difference when there are multiple color stack frames. They're always in order, but the color makes it even clearer. Thank you, Zaid. And whenever we have an object being created from a class, we get copies of all of their instance variables. And these instance variables are initialized as soon as they're declared. So we're going to put battles1 of 0, a new variable, exp points, experience points 0, and I got reference 002. So the value of this in this constructor is 0x02. And then we run the constructor itself. All the parameters go on the stack frame. There are none. All of the code is executed. There is none. So nothing actually happens in this constructor. Nothing extra. All we got is the instance variables. And since we initialized the instance variables in line like this, we did get some stuff happening. We got the instance variables with their initial values, which are the same for every single character. Everybody starts with no battles1 and 0 XP. So this method can just return right away. It returns to this variable. Cross it out. OX02. Now notice one thing that didn't happen here. I see this mistake all the time. And we spent quite a bit of time in the last TA meeting talking about how to handle this on the grading side. I forget what the resolution was. I think it should probably be a fail, but I forget what the final answer was. But inside this constructor stack frame, what's not here are the instance variables. Do not put your instance variables in your constructor stack frame unless they're constructor parameters. You only put the constructor parameters in there and any local variables created in that method call. The constructor is just a regular method call that happens to return a reference to the object that was created when it was called. The object creation is completely separate from this stack frame. This stack frame has nothing to do with the object being created aside from returning a reference to it and having a reference to that object in the keyword this. Battles1 and experience points do not go in that constructor stack frame. And this gets even muddied up a little bit more when, for example, the player class, we saw this right from our first constructor calls, the player class had 3 instance variables but only 2 parameters. The 2 parameters went in the stack frame, and that third instance variable, HP, did not go in the constructor stack frame. And I should have emphasized it when we were going over that one. I guess I didn't really, maybe that's what we can do if we have more time. I didn't get to finish that one. I did put the final diagram in the, oh no, I did. I put the final diagram in the slides, and yeah, we did open up the slides, and I zoomed in, and it was really awkward, and just hit the points that I wanted to hit on it. So we kind of finished it. But that's one thing I want to emphasize. The constructor only gets its parameters. These instance variables that are not constructor parameters do not go in the constructor stack frame. Stop putting them there. Yo. You would follow the code. So the question is, if there are parameters to the character class, so if I had, and I can actually edit this. If I had battles 1. If I have battles 1 here, I'm going to put battles 1 in this stack frame, but it depends on what the code does. If I never have this dot battles 1 equals battles 1, then I don't do that. But if I did have this dot battles 1 equals, maybe this might be exactly what you were asking, I might have misheard, then you would still put the 0 here, cross it out, and then replace it with the new value. Because it will still be initialized. This happens before the constructor code is called. So you would set it to 0 and then replace the value. Out of here, so make sure we're back to the original code. Didn't change the diagram at all. Okay, sorry, what's up? Yeah, so when I had the int battles 1 here, I would have to put a value here. So if I had int battles 1, then I would have to put in all these constructor calls, I'd have to put the initial battles 1 that I want. Then I would put this dot battles 1 equals BW in that case, if I want to initialize that. If I take a parameter and I don't say like this dot whatever equals, if I don't assign it, then it doesn't automatically go to the instance variables. I have to actually assign it to the instance variables. So if I take a parameter and don't do anything with that parameter, it doesn't have any effect. But we usually... In this, for this code right here, this is it. We wouldn't add anything else. But if we had a parameter to the character class, and we'll... Oh, no, we won't see that today. Like for the part... I'll get there. For the... Player? Was it player? For the player class, we did have constructor parameters, and then we put those parameters in the stack frame. But with no parameters, there's nothing to put in the stack frame. We have no parameters and no variables declared in that method, so nothing except this. Yeah. They're only created when a constructor is called. So when a constructor is called, then we'll create this object on the heap with all of the instance variables for that, an object of that type. So when Java goes to the operating system and says, hey, we need some space over here, it's going to ask for enough, in this case, enough space for 2 integers and any overhead for the character class, for an object of type character. It's going to ask for exactly that much space and then allocate that space for those variables. And then that space on the heap is where I store those 2 ints. But that's the only way to get those variables declared. It's a constructor call. Okay, and then we do the silly thing of character, this. Get my return arrow right away. Here, I'm going to misspell character at least once today. I don't think I did yet. Battles 1, 0. So we create the instance variables. We do any initialization here. And then we execute the code in the constructor. But we always declare the variables first and any initialization that's set when they're declared, and then we run the constructor. So the order is important, not necessarily for things we'll do in this course. Those are pretty tricky questions on quizzes that, do I care if you memorize the order? We'll just give you code that the order doesn't matter, but it is important throughout your whole career, like something you should keep in your mind. This is going to happen first before the declaration. Or just, if what you keep in your mind is I don't remember the order, so I'm not going to write code where the order would matter. That's perfectly fine. Just write code like that. Okay, and then this got OX003. This returns. Cross this out. OX003. Oops. OX003. So at this point, nowhere in memory do I have a reference to OX002. This object cannot be accessed anymore. I have no possible way. Remember, stack frames that are crossed out are actually deleted from memory. They do not exist anymore. So that OX02 on the stack is not there. I have no way. There's zero code at this point, at this stage of the program. There's no code I could possibly ever write that's going to be able to access this object ever again. It is gone. So Java is going to say, well, I can garbage collect that. And I say it's a candidate for garbage collection. Whether it's actually garbage collected or not, that's up to Java to decide. In this case, probably not, because the program's going to end in like a millisecond. Java might not have an opportunity to get in there and clean it up. But it's a candidate for garbage collection. To us, it's effectively deleted from memory. And Java, when it gets to its cleanup process, it'll end up actually deleting it from memory. But this object is gone. It's completely gone. Can you call a method 1 and method 2 inside of the method body, and method 1 is also in the method 2 body? Sure. Yeah. Yeah, why not? It's like a two-method recursion, the way you explained it. As long as there's some conditionals, so they're not always calling each other, because then you're going to have an infinite cycle. So as long as there's some way to break that cycle, yeah, why not? Yeah. Is the new value? Oh, yeah, it looks like I put two variables there. Oh, I see what I did. OX03. Let's get that fixed. We want a nice memory diagram here. Oh, no. They'd fix it. Oh, there we go. Zaid, you don't have to fix it. Oh, I see what it did. No, I'm just dumb. That was user error. I clicked remove arrow. Oh my goodness, I'm remembering. Speaking of Zaid, there is, no, I don't know the details off the top of my head, but there's a review session. You should all go to it. Can we take a little detour? Yesterday, but it's weekly. Bi-weekly? Okay. Thursdays, y'all can help me out then. Thursdays when? Thursdays at 5 in NSC 220. I know the room because I booked the room for them. I forgot the date and time. Every other Thursday, and there should be a Piazza post, that's what I was going to try to dig up real quick here. There should be a Piazza post explaining it. But go there if you want some extra help on the material. He goes over it as a review session style and gives more information about things. And he's the one who built the grading tool. So especially memory diagram focus, like he'll be like the guy to talk about with that. Especially, I shouldn't say especially, but if you have complaints about the tool too, he'll be happy to take feature requests, whether he does them or not. Depends on what your request is. But if you have reasonable requests, he's pretty open to updating this and making it the best tool that it can be. So if you want help with especially memory diagrams, go to review session. He asked me to advertise. I keep forgetting in lecture, but I remembered this time. So in 2 weeks, Thursday, 5 at NSC 220, review session. Hit it up. Well, I fail the quiz if I forget to cross out the stack frames. So speaking of, wait, let me make sure I didn't miss anything. So we are not crossing that instance from the heap. No. Is there? I don't think there's a feature for it. No. There's no feature to cross it out. So what we used to do when it was pen and paper is actually put a big old X through it, but we have no method of doing that. You can delete the object, but that completely erases it like it never existed. we would want it to be crossed out like a stack frame to show that it did exist, but now it's not in memory anymore. Deleting the object means, oops, I made a mistake just like I did with that variable. Let me fix my memory diagram. So we don't have a way to do that, but we would if we did. But really, that's just something I don't care that much about. We have so much other stuff to cover in this class. Crossing out your garbage collected objects is very low on my priority list. Yeah. Yes. Oh, and I wanted to come back and circle around to this. I just want to make sure I didn't miss a question in there. So in terms of grading, I want to talk about how we grade these things. We have three different types of errors, three different levels of errors. There's the minor errors, so not crossing out your stack frame would be a minor error. Major errors, which, I don't have an example off the top of my head. Making a mistake that's major. And then what we call instant fails. So the instant fails, those are the ones I really care about. If you make any instant fail mistake, you're done. That's a fail on the quiz. You can make a few major errors, or one major error, I think, is what we landed on, and still pass. That's fine. But once they hit two, I think it's two majors is a fail. And then minors, I think you can make 2 or 3 minor errors and still pass. Not crossing out stack frames would be a minor error, so you can make a couple of those. And if you don't cross out any stack frames, that's counting as one minor error. Forgot to cross out stack frames. It's not like, oh, there are 5 stack frames, so that's 5 minor errors you failed. That's just one, so what kind of mistakes? Another minor error would be a math mistake. If you have all the right values in your memory diagram, and then at one point it's clear that you added instead of subtracted, that's one minor error you can easily still pass. And then the TAs are trained to watch if that cascades. Like, okay, now you have the wrong value in that variable, that instance variable, the wrong value on the stack frame, and the wrong value printed out to the screen. If that's one mathematical error, that's just one minor error. It doesn't cascade like that. The instant fails are the scary ones. Those are the ones you have to watch out for. For this quiz next week, our first graded, the other ones were graded, but the first one that counts, you know what I mean. The major errors that I really care, that I want listed as major errors, I don't know their exact list, but it should be this list. If it's not, I'll yell at them. Having the wrong number of objects on the heap, that's an easy fail. If you, for example, in the player example, and this will be tested next week, 100% guaranteed this will be tested, is we had like P1 equals new player, P2 equals new player, P3 equals P1. That P3 equals P1 is an assignment by reference. It's just the reference that was assigned. There was no third player being created. So if your memory diagram in that example has 3 player objects on the heap, that's an instant fail. You clearly don't understand references. And references, constructors, objects, the heap, those are all the big concepts that we're assessing. Any mistake there, you don't understand the things you need to understand. So those are instant fails. Too many objects on the heap, not enough objects on the heap. So just wrong number of objects on the heap, you fail. Forgetting your keyword this. If you don't have this with a reference to the calling object, that's instant fail. You need to have this. You need to understand that non-static methods have a reference to the object that is calling them, or for constructors, the object that's being created. Missing those, I would go as far as missing, well, I don't know. If you miss this one single time, maybe that would be a major. I would probably count that as a major instead of an instant fail. Because you knew what to do and you just forgot to do it one time, it's probably only a major. But if you never have the keyword this, you never have references like that, instant fail, easy all day, you're failing for sure. If you have a method that takes, really though, if you have never have this in a stack, we have 2 stack frames here that only have this. If those 2 stack frames were empty, like you don't know what's going on at that point. If there's a method that takes a reference to an object and you don't handle that pass by reference the right way, if that parameter doesn't have a reference to the object and that object is somehow not updated when it should be, and then you go back to the main stack frame and access the same object through a different variable, but it's a reference to the same object, it should see that change that was made in the method that is passed by reference. If you're losing track of your references during all that and not understanding that I gave it a reference that's a reference to the same object, so everybody sees those changes if it's a reference to that object, any mistakes in that, it's going to be an instant fail. And that's about it. That's a pretty comprehensive list. Wrong number of objects. The keyword this, not happening. Constructor stack frames not existing at all. If you just go to the heap and create the object without your constructor stack frame. And messing up your pass by reference. Those are like the 4 big things that I look for in a classes 1 quiz. Yes? Yeah, and I forget the exact numbers, but the grading team has a list. Like you can make 1 major and 1 minor. I forget what the exact numbers are, but there can be some combination of them. But 1 instant fail, messing up those 4 things I just mentioned, you're done, and no sympathy for me, there's nothing. If it's like, you have 3 minors and you think the grading team went a little off the rails, that's where I might step in and, we can work something out potentially. But you make any one of those minor errors, like that's what I'm teaching you this week. You need to know those things. Okay, speaking of teaching, let's see. This is going to take me way more than half an hour. Okay, let's get on with this. Okay, so I need a new variable here. We're going to create this fighter, and we're going to run through the same thing. I don't have much new to talk about with the fighter, but let's get this in here. We have another character. Keyword this. I always write this as soon as I put the stack frame down so I don't ever forget to do it. We're going to have a return arrow. We're going to have a character. We have a parent of the yellow character. We're going to have battles 1, 0, new variable, experience points, 0. We got 004, OX004, cross this bad boy out, and OX04. I don't think I have to explain anything new. We're just getting some characters on the heap so we have something to work with in the rest of the code. All right, then hero.winBattle. Here we have a method call. We're going to have a winBattle method call, so we know that much. And we only put the method name when we put our stack frames on. Yeah. Oops. Like that? Because I clicked the wrong thing, sorry. Okay, so we have a method, winBattle. This is a non-static method. Most methods through the rest of the semester are non-static, so just get in the habit of putting this in your methods. This. And this is a reference to the calling object. Hopefully I've said this enough times, but maybe not. I don't know. I missed part of that memory diagram on Monday. So let's hammer it home right now. Hero.winBattle. Hero, I'm going to the hero variable. It stores the reference OX003. Dot means follow the reference to the object. So dot takes me to this object. And then while I'm at this object, I'm calling winBattle with an argument of 10. So when I called winBattle, I was at this object right here. So this is the calling object. This is the object that called the method. So when I call this object, or call this method through this object, this is the calling object. So this is going to be the reference OX003. This is a reference to the calling object. How did I get to this method call? I got to this method call through hero.winBattle. Hero was the reference OX003, so this is the calling object. This in that stack frame is OX003. Yes? Yeah, so state and behavior, like the party class, has this state. State is all the variables, all the instance variables that end up on the heap. And then behavior is a collection of all the methods for that object. So like a character has this state. State is the variables. And then behavior has this win battle method. That's the behavior of a character object. What was that? For objects of that type. Well, and the state can be different for objects of the same type. But yeah, the state can be different per object, but the behavior of objects of the same type will be the same. Okay, so win battle called by OX003. And in our code, we tend to think of the calling object as being hero. It's can be a bad-ish habit to get into of thinking of this character as hero, as the hero, as, and more specifically, as its variable name. I have a variable that stores hero, but I won't always have a variable. I can have references to that same character object, OX003, that's not through the variable hero. So we do think of it as, oh, that's the hero character, but it's really the character OX003, and I can pass that reference throughout my code without necessarily having it associated with the hero variable. Bless you. So I'll call it OX003. So I have this, a reference to this object, OX003 of type character. We call win battle with 10. So XP is 10. And then we execute this code, this.battles1++. And when we're doing memory diagrams, I'll recommend this throughout the semester. When we're doing memory diagrams, the weirdest advice I like to give, but solid advice in my opinion, is to kind of turn your brain off a little bit. When we get to a line like this.battles1++, don't try to reason about what's actually happening here according to the logic of your code, because you might be tempted to say, okay, I'm in this method. It was called by hero.winBattle, so hero reference to a character. We're calling it on the hero character. That can get dangerous. It can get, at best, exhausting, mentally exhausting if you're doing that on every single quiz. What we're going to do is turn our brains off a little bit and take advantage of the fact that we have a memory diagram. This.battles1++. What's this? We're in the active stack frame, the one lowest on our diagram that's not crossed out. This is OX003. I'm not thinking, okay, this is the character stored in the hero. I'm not doing any of that. I'm just flat out doing what the computer does. This is right here in the stack frame, OX003. Dot means follow the reference. I'm going to head over here to this object. Then battles 1. I'm at this object after the dot operator. I'm no longer in the stack frame. I'm at the object. And I'm doing dot battles 1. I'm looking for a variable named battles 1. Here it is. What am I doing with it? Plus, plus, baby, 1. Incrementing it by 1. So I'm not overthinking things. I'm just blindly following what my memory diagram's telling me. This dot exp plus equals exp. When we resolve another expression, we start over at the stack frame. So xp, what's xp? 10. Cross this out, replace it with 10. That's the end of this method. It didn't return anything, has return type void, so I don't have to worry about a return arrow or anything there. And we move on. We're going to create a new party. Let me get my variable first. Party. Party. This. Party. Parent. Party has members. And battles 1. Battles 1 is initialized to 0. I'm going to circle back to, I shouldn't have done that one yet. Let me get my OX05. This is a reference to the object being created. And then when we're calling the constructor, oh, actually I did this right. Technically this gets the value null. I'm not going to require that on any memory diagrams. Technically it gets null and then the null is crossed out. Not worrying about that though. And then we call the constructor code. We created the instance variables, put them in the object, and then we call the constructor code. The constructor code is going to set members equal to a new array list. And whenever we have stack frames that are technically there is an array list constructor stack frame called here, but whenever we call methods that are internal to Java, we're not going to bother tracing it in our memory diagram. We want to trace our code when we're doing this to understand how our code works. We don't care about the internals of Java, and plus we don't have the array list code handy, so we don't know exactly what it does, what the instance variables are, or any of that stuff. So we're not going to worry about it. We're just going to create the array list. Create an array list. It has no parent because we're not bothering with its constructor stack frame. And it's not going to have any values, no variables or values yet until we add things to it. And then this reference, this is what gets stored as members. So we have composition here. We have an object that has an instance variable that stores a reference to another object. And yes, we can do that. This is going to return right here. This is going to return, and this gets 0x005. Next line, party.add character of hero. Create stack frame, party.add character, party. We're at 0x005, so this is the calling object. Add character. It's this. 0x05. Create new variable. Member. Member is hero. I'm not going to think about what it is. I'm just going to look at my stack frame. That's what the computer does. It just looks up its stack frame, looks for the variable with that name, looks at the value next to it, 0x03. 0x03. And this code will add it to the array list, but we're just going to not think about that. We're going to follow the line. This dot members, we find the members variable, dot add. So we're calling add from this array list here, 0x06, since that's internal to Java. And the rule of thumb is if we don't give you the code for the method, you don't have to trace the stack frame. Because what are you supposed to do? You don't know if it creates local variables, if it has code blocks or loops, whatever. You don't know. So we just don't trace it. But we do have to know that the effect that'll have is adding at index 0 the value member 0x003. And each time this is a new expression, each time it's a new expression, you start over at the stack frame with your resolution. You're not resolving member at the array list. So we're going to add that member, cross this out, and I'm going to use this fancy clone method. Clone, we're going to add fighter. Fighter is 0x04. So I get to add to this array list 1, 0x04. So we have the two characters added, and then party.win battle. Oh, in a couple minutes. I don't think we are even getting to the end of this. Win battle. This called through party. With a parameter of 20. So win battle in the party class. Notice we have two methods, both called win battle. So which one is called? We haven't talked about this yet this semester. It will be a big topic later. Which method is called depends on the type of the object. So when we're calling this through our party object, we go to the party class to look for the win battle method. So this win battle method, which has XP, we're giving it 20. And this win battle method will do this dot battles 1. This dot battles 1 plus plus. And then a loop. X equals 0. That loop is going to hit this line. This is the line I want to get to. We got to at least get to this one time, and then I'll be fine if we don't get to the rest of it. This line is going to bounce all over memory. We have to go through quite a bit here. So we're doing this. This in the stack frame is 0x005. So dot, take me to 0x005. Look for a variable named members. Members is a reference 0x006. That's what this dot members resolves to, is 0x006. And then dot means take me to that object referred to, dot get. So we're calling the get method from this array list with an argument of x. X is a new expression, so we go back to the stack frame to look at what x is. It's 0. So this whole thing here resolves to 0x003, the value at index 0 for this array list. And then we're saying dot, so 0x003, take me to your object, heading up to this object and calling win battle from this character here, 0x003. So when we finally get to the win battle stack frame, we're calling this through 0x003. So after all that bouncing around memory, we get to 0x003. That's of type character, so we're calling this method xp 20. And notice that our code block, we call the method from another method. Our code blocks never, ever